There's a small school in the village of Landwa where I grew up. In front of it stands a statue of my great-grandfather, Shri Tibhuvan Das Patel, a fearless advocate for farmers who helped set up the first groundwater tube wells in our area. My Dadaji taught me that a nation's strength rests in the hands of its farmers. That's the legacy I carry forward. With him, I spent time on the fields interacting with farmers. When I spoke to farmers like Rakesh Bhai and Manu Bhai, their concern was clear. Our wells are drying and we're running out of options. Bore wells are often drilled over 600 feet deep. There is no irrigation infrastructure, no pipe systems, and barely any access to technology. Farmers still rely on flood irrigation, wasting water, damaging soil, and deepening the crisis. And they're not alone. 60% of India's districts face critically low groundwater levels, yet over 70% of farmers still use flood irrigation. Agriculture consumes nearly 90% of India's fresh water, most of which never reaches the roots. With over 256 districts declared drought-prone by Indian authorities, this is a national emergency. That's why I created SaurSinchAI for smallholder farmers. From faint ideas to hardcore realities, the evolution of my Agribot SaurSinchAI. The journey of making this bot involved continuous iterations and a cycle of failures, brainstorming and problem solving. My first creation involved a chain wheel drive powered by a motor on each side. This caused a significant torque deficit and utilized excess power, drastically cutting the battery life. The original 12-volt battery was too small to sustain extended operation. I decided to eliminate the chain drive and add 2 more motors for enhanced torque and make maneuvering on the soil easier. I also upsized to a 24-volt battery that supported all 4 motors. The initial prototype exhibited high torque demand on the drive motors right here, significantly reducing the turning efficiency. The 304.8 mm tires lacked adequate ground clearance and traction across variable soil textures, compromising mobility. The steel water tank introduced excessive dead weight and corrosion risk, negatively impacting power efficiency. The exposed IoT hardware was vulnerable to environmental interference and mechanical damage. Lastly, the 0.1 mm misting nozzle suffered frequent clogging and failure due to unfiltered particulate intake. My second prototype was equipped with small tires to reduce the turning radius, but these tires got stuck in the soil. So to increase traction, I changed to larger solid tires. I lightened the spray part to reduce its weight, added an anti-corrosive coating inside the water tank, installed a strainer at the tank outlet, and covered the exposed IoT hardware. Now, this is my near final Agribot. Here we have a pump with a 12-volt and 6 liter per minute capacity. Next, which is connected to a flow meter, and here is our intake valve to control the amount of water we spray into the pipes right here, which goes into our 0.1 mm nozzles over here with an adjustable spraying length. Over here we have 2 driver cuts. This one has a 10 ampere capacity and this one has 30 amperes. We use a 10 ampere capacity as we're only using the flow rate, which doesn't require a lot of current. Next, we use 30 ampere capacity here as we're using it for the motors, which require a higher amount. We have attached 4 motors and 4 tires. The tires have a 16 by 4 inch and these are 250 watt motors with 60 RPM. Now here we have our solar charging unit, which is connected to us for the power panel here. Here we have our MCB switch, is our main switch, is our switch for the solar panel. If we flip this switch, our solar charging will discontinue, and we turn this on, we will directly switch to the bypass and go to the 150 mAh milliamperes per hour battery over here. SaurSinchAI is remote operated at a frequency of 2.4 GHz. Like this, we turn it on and we can move it back and forth with the controller right here. SaurSinchAI measures soil health data via an Arduino based controller ESP32 connected to an isolated soil sensor, which measures nitrogen, phosphorus, potassium levels, soil moisture level, pH level, electrical conductivity, and temperature. Integrating multi-zone soil moisture sensing, the control system utilizes crop type and field data to estimate irrigation needs, schedule spraying, and sends alerts to farmers' phones via GSM without requiring internet connection. Even after such diligent work, the bot still sank into the soft soil, overwhelming me and my mentor. My motivation to create an innovative solution for sustainable farming and advanced agriculture technology for my community, combined with my resilience, kept me focused and driven towards my dream of developing the Agribot. Ultimately, during the final refinement, I switched to larger, low-pressure pneumatic tires for improved flotation and traction, added an articulated joint for steering, and paired it with rear-wheel drive to enhance mobility and reduce the turning radius. In KVK validated pilot trials across 15 castor farms in Landwa and nearby villages, SaurSinchAI saves 60 to 70% of water and increased yields by up to 30%. Thus, I created my final go-to-market version. I received commendation from the Honorable Chief Minister of Gujarat, Shri Bhupendrabhai Patel, for my innovation SaurSinchAI and my contribution to the farming community through Krishi Mitra. I earned an International Crest Gold Award, had my innovation patented and published in the official journal of the Patent Office of the Government of India. SaurSinchAI also received formal recognition from the Indian Council of Agriculture Research, ICAR, Division of Agriculture Engineering, which led to my winning the National Youth Icon in Farm Mechanization Award. To scale my Agribot and facilitate broader adoption, I founded my startup, Agrinova, and secured a grant from the Incubation Center at Kanpur University. I have also pitched to the Directorate of Agriculture Gujarat to subsidize my Agribot to extend its reach.
મારું નામ પટેલ કિરણકુમાર નારાયણભાઈ છે, ગામનું નામ દેલોલી, તાલુકો જિલ્લો મહેસાણા. ગઈ સિઝનની અંદર મેં આ સૌર સિંચાઈ એગ્રીનોવા કંપનીનું મશીન છે એનાથી મેં એરંડાની ખેતી કરી હતી, તો એની અંદર મને ઘણો જ ફાયદો થયો છે. એક ખરેખર સાથી મિત્ર તરીકે આ કામ કરતું એવું મને લાગી રહ્યું છે. પાણીનો 70% જેટલો બચાવ થયો અને ઓવરઓલ આપણે એરંડાની ખેતીમાં ગઈ સિઝનમાં મેં જોયું તો 35% જેટલું ઉત્પાદન આપણને વધારે મળ્યું છે.